Hey everyone, my name is Anvita Bansal and welcome back and very happy new year to everyone. So we were discussing linked list from our SD sheet. So let's move to the next problem that we are going to start off with today. It is intersection point in Y-shaped linked list. So let's have a look at the problem statement. Okay, I'll just quickly check if I'm live. Fine. Starting off with the problem, so what it says is that you are given two singly linked lists of different sizes n and m. Write a program to get the point where these two linked lists intersect each other. Okay, so let's have a look. The input that you are given is in the form of like this. You will be given the head one of the linked list of length n, let's say, and head 2 of the linked list of length m, let's say. I'll just show you everything, and you have to return the data, this data at the node at which these two linked lists intersect. Okay, you have to return the data or the value of that particular node. So let's have a look at this problem statement and we'll discuss how to solve it. Fine. So this is the test case that they have given. I'm writing it like this. So you have 3 pointing to 6 pointing to 9, 15, 30. Okay, 9, 15, and then this is 30. And there is this other linked list which starts off at 10. Later on it points to 15, then 30, and so on. Okay, and the next of it is null. Now what do you have to do here is that you need to return this node at which these two linked lists intersect. Got it? Okay, so the brute force approach, or maybe the approach that you can start off with, and is that you see that the two lists differ in some size. Okay, first thing is we can iterate through one linked list starting from head 1, let's say, and we can iterate through other linked list starting from head 2 which points at 3 and head 1 pointing at 10. Then you check what is the length of the list that starts at h1. It is 3, right? 1 2 3, 3 for h1. The length of the list starting at h2, that is 1 2 3 4 5, right? So what is the difference in the lengths of two linked lists? The difference is exactly of two nodes, right? 5 minus 3 is the difference in the length of these two lists. So what is my target? Why did I find this difference in the length of these two lists is that why not start the iteration of the bigger linked list from that node itself, which is actually creating the difference in the lengths. You getting my point? So you see that the smaller length list is of size 3, fine, and the bigger one is of size 5. So why not move my head to the node from where if I start I can equally traverse the linked list, means by exact same number of nodes. So if I point my h2 at node number 9, don't you see that h1 and h2 are at the same level? So for that, what did I do? I basically moved h2 to 2 nodes ahead, and these two came from the difference in the lengths of these two linked lists. So the entire intuition behind this approach is that you bring your iterator of the bigger linked list at the node from where the h1 and h2 can be at the same level for both the lists, and then you start iteration until h1 becomes equal to h2. So the moment where these two nodes become equal, you return the data of that particular node. Point to note here is that you have to check that h1 the nodes become equal and not just the data. What do I mean by this is, for example, if I alter this node by value 9, for example this was 9 and h1 is pointing to 9, h2 is also pointing to 9. So are you going to say the intersection point is 9? No, the data might be same but the nodes are different. This 9 belongs to the different linked list, this 9 belongs to a different linked list. So you have to find the exact node which collides. So this is the collision point where two pointers become same, right? So that is one thing that you have to note here. So this was about this approach. The problem with this approach is that, see, first you are finding the length of bigger linked list. So entire n1, let's say n1 not n, let's take n and m. So let's say this is of length n. So first you travel through n, then you travel through this list to calculate its length. So you take m, and then you again travel through the bigger linked list that becomes around twice of n. Again, let's say because you are traveling through this, you are first of all making your h2 point at the other node, and then you are doing this traversal again until you get the same node. For example, the intersection was the last node. So you are minimum traveling the length of the smaller linked list once again. So this is typically n plus 2m. Okay, so we can definitely improve this method. We can optimize this approach. I hope you understood this one. So in order to optimize, what are we going to do here is, let's have a look. I'll just write this test case again. Give me a moment. So the intuition behind this is, I wouldn't say that it is the approach that we are going to start off with. You need to understand first, and then you might be able to understand why we did so. I wouldn't say it's very intuitive, okay? But let's see what are we going to do. I'll just copy this test case. So we have 3, 6, 9, 15 and 30. Right, the next pointer is null, and then we have 10 of the other linked list pointing to 15 and 30. That's how it is going to look like. What are we going to do here is that, let's do one thing. I am taking, this is your head 1. Head 1 is already pointing at 10. Okay, head 1 is already pointing to 10, and head 2 is already pointing, it is given in your question. See, I'm sorry. So these two nodes are already given in your problem statement as head 1 and head 2. Okay, so I'm just taking another temp variable pointing to both the heads. So head 2 is pointing to 3. Now let's take head T1, which is pointing at head 1, and T2, which is pointing at head 2. Okay, I'll do my iterations using T1 and T2. This is T1, this is T2. So let's start moving them one by one until they become null or they become equal. The pointers point to the same node. So let's see what are we going to do. Bring T1 to T1 dot next. In first iteration, T1 comes here, and same goes with T2. T2 comes here. For the next iteration, now your T1 was pointing here, it will go to T1 dot next, which is this, and T2 will go to its next, which is this. In the next iteration, T1 will go to null, and T2, as moving ahead to T2 dot next, will come here. Now when you see that T1 is pointing to null, okay, I see that T1 is pointing to null. So what should I do? Should I bring it back to head 1 and do the iteration again, or should I bring it back to head 2 and do the iteration? See, whenever one of the nodes hit null, do one thing, make it point to the head of the other linked list. So T1 belonged to this linked list, bring it to the head of the other linked list. So head of the other linked list was this. So now T1 is pointing to this node. And repeat your iterations. For the next iteration, your T1 comes here, and as usual T2 goes here. Okay, next iteration, T1 comes here, as usual what we were doing, T1 dot next, T2 dot next, and T2 comes here. In the next iteration, what I find is that T2 is pointing to null. So when I told you, whenever one of the pointers is pointing to null, make it point to the head of the other linked list. So T2 belonged to linked list number 2, this linked list. So make it point to the head 1 of the first linked list. So T2 right now is at this position. Do you observe that T2 and T1 right now are exactly on the same level? And repeat the process, bring T2 to the T2 dot next, and T1 comes at T1 dot next. And while you are moving, you are also checking at any point if T2 becomes equal to T1. So this is the point where T2 becomes equal to T1. So I simply return data of any of these, return T1 dot data. Okay. So first thing, I showed you this step. Okay, you understood this thing, but I'll come on to how it is handling all the cases. I'll just show you. and why we did so, that also I'll come on, why we are doing so, and how is it ensuring that T1 and T2 will give me the collision point somehow. So let's have a look. See, what are we trying to do here is, what if, first take other examples. For example, in this case your linked list was of different length and you had a collision point. What if you never have a collision point? For example, you have a linked list like this, 10 pointing to 20 pointing to null, then you have 3, 6, 7, 11 and null. Okay, you are doing the repeating the same things. You're moving, bringing T1 here, T2 here, you do T1 dot next, T1 comes here, T2 comes here, then T1 comes here, it becomes null, T2 goes here. Now as per our algorithm, whenever one of the nodes become null, I make it point to the head of the other linked list. So ideally T1 should be pointing at this node. Even when I'm pointed at this node, are they ever going to collide? No, because there is never a collision point. You getting my point? There is never a collision point. So let's keep doing this thing. For example, now next iteration, your T2 comes here, T1 comes here, and T2 comes here, then T1 comes here in the next iteration. Right now T2 is null, so make T2 point to the head of the other linked list. So T2 comes here. Now you see T2 and T1 are on the same level, so when we keep iterating to T2 dot next, in the next iteration T2 comes here, T1 comes here, next iteration T2 goes here and T1 comes here. So what can we observe here is that either both the, see, there is the case when T1 and T2 were equal, I return T1 dot data, because that was not null that time. But in this case, again, I can see that T1 is equal to T2, but the problem is they are pointing to null. So in that case, you should return -1, which ensures that there is no collision point. So you are returning -1, right? I hope you understood this point. So in that case, -1 will be returned directly. That thing has been handled. I'll show you the code where we are handling this thing. Now talking about other case, let me think if we have missed something. If, for example, what else could we miss? I'm just thinking if there's something that we have missed and probably not handling. I think that's it. And this is about how this method, this optimal approach, will ensure that T1 and T2, whenever they become equal, okay, that we are returning them, that means there is a collision. If any one of them is pointing to null, we make them point to the head of the other linked list, right? And finally, till when are we going to do this thing? While your T1 is not equal to T2. This is the breaking condition. When do you break this while loop? See, while T1 is not equal to T2, you are doing T1 pointing to T1 dot next, T2 pointing to T2 dot next, and also there are 3 conditions here. If T1 becomes equal to T2, you directly return T1 dot data, okay? Other conditions are, if T1 is pointing to null, I am writing these conditions before them, or maybe you can write after them, doesn't matter. The other conditions are, if T1 becomes null, if T1 becomes equal to null, then T1 is pointing to T2. If T2 becomes null, which I have already shown you, T1 is pointing to head 2 and T2 is pointing to head 1. And you do repeat the process unless T1 becomes equal to T2. Finally, you return T1 dot data, right? So that was all about it. And I'll show you the code quickly. I'll write a shorthand code which you can understand. Obviously, that's not very understandable, but I think you should also know the shorthand way. At times, it makes code a better one. Fine. So, okay, before we move on this, the time complexity. So you can see that at max, we are moving through all the nodes of smaller linked list and all the nodes of the bigger linked list. So it's typically O(n) + m only. Okay. So let's see. Okay, what I'm doing is, for example, if your head 1 itself is null or your head 2 is null, if any of these is true in the beginning only, that means there is no collision point. You getting it? So you should return -1. Fine. Now I am writing a while loop for which let me define node t1 pointing to head 1, node t2 pointing to head 2. Fine. Now I will iterate through them until they become equal. So while t1 is not equal to t2, correct? What I am doing, I am checking what that make t1 equal to head 1. One second. t1 becomes equal to t1 equal to null. If t1 is null, then make it point to head 2, right? Make it point to head 2. Otherwise, make t1 point to its next pointer, t1 dot next. Okay. Same for t2. t2 is point, if t2 is equal to null, okay, if this condition holds true, this particular case is true, then you are making it point to head 1. Otherwise, you make it point to its next node, t2 dot next. Fine. And when you come out of the loop, that is the condition. That means you have found a collision point for sure. So t1 and t2 will be pointing to the same node. So you can simply return data of t1 dot data. Let's check. Why is it taking so much of time? Missed something. Let me check. t1 is pointing to head 1, which is a fine case. Just a second. t2 is pointing to head 2, while t1 is not equal to t2. That t1 is pointing to null. If t1 is equal to null, point it to head 2. Otherwise, t1 dot next. If t2 is equal to null, make it point to head 1. Otherwise, what is wrong then? I don't. Let me check. This is the case for which it is not returning -1. We are making it point to the first node. t2 is pointing to the second node. Let me see what is the issue. Taken t2. Well, I don't see an issue here. Don't know. Let me check. Let's see. Let's check what is the issue. I think, didn't we do the same thing? h1. I think there was a, what did we do? Let me check my submission. What mistake we made? is also not working now. And this was a submitted code. I think there is some issue. Let's check. See, this is the correct code. Now I have moved it. Let's see if it's working. I think you can ignore it. Probably there is some issue from the backend side. Have we missed something? If I add null or h2, and h2 equals null, return -1. Yeah, I think it's fine now. So there was some maybe a backend update in this question. Previously it was taking, actually when we were not handling this case, even then it was submitting. You can see that was correct already. So what was an issue? This code without this was not handling the case where these two linked lists are two different linked lists which never have a collision point. So we just added this step. Whenever h1 and h2 are pointing to null, even in that case, means we do not have a collision point, so you return -1. So I've just added one extra line to handle that case, and that is all about it. Let me check if you guys have any doubt. That is all about this problem, guys. So let me know if you have any doubts. We are done with this question. I think there is no even need of this check. Let's check if we need it or not. Let me check. We can assume that head 1 and head 2 are not null initially. Yeah, I think it will work. So you can take this one as a takeaway for this problem, in which we have handled all the cases. Okay, even if we have collision point, even if we don't have a collision point, and that is all about it. Fine. So that's all, everyone. Then if you have no doubts, we are wrapping it up. Okay, see you all in the tomorrow's lecture. Thank you and take care. Bye.